So this is what my title of the presentation: Mathematica method, interactive method in solving and visualizing physics problems using Mathematica. So this is the plan of my presentation. This is the outline. So a few words about our university and then my contribution to the teaching and research and growth of the university. There are some inspiring quotes by the people, scientists. Then introduction to solving and visualizing physics, mathematics, chemistry, science, and biology. And physics, what will you do and how will you do growth of physics? Solving and visualizing mathematical problem, where mathematics is a set of powerful skills for turning ideas into reality. So there are powerful tools that are available to turn your ideas into reality. And then solving and visualizing the physics problem. First is dynamics of free fall and accelerating objects, radiation problem, birth of quantum physics, wave motion, quantum wells and barriers, energy bands in solids, and then electrodynamics. We have a gradient, del, and curl. What are they? I do not know whether I can complete all of them, but whatever is possible, we try to see that we have some ideas that is going to emerge by using this kind of a powerful software. So this is what our university location. It is there in the Pondicherry somewhere here, and it is about 140 kilometers from Chennai. And these are the present position or present strength of the departments, and then various departments, and these are the affiliated institution. And I have completed 30 years work in teaching as a teaching faculty, various levels, including vice chancellor in charge for the Pondicherry University for some time. So this is what my background in the Pondicherry University. This is what you are in. Okay, and what is the contribution towards my research? These are the journals, research journal over the period of time I have published, and these are the number of publications. And this is the various works in the workers in the national and international level, and their contacts and their interaction. They are all interacted. Continues to have an interaction with these people. Some of them are past, old people. There are some are alive. They are very active now. These are some of the people in which I have the contacts, and then there is an interaction. There is something being contributed also, and all being compiled now in the form of a. We have some interesting research that I'm putting in the form of a textbook, Dielectric for Impedance Spectroscopy with Mathematica, Understanding Dipole and Charge Carrier Motion. This is under preparation, and I hope another year time or so I would like to complete that. And what about the contribution to the university? This is my contribution to the university in terms of establishing the facilities. Like you can see the 25 major facilities that are being established during my tenure as a coordinator of the center, and this experience gained a lot for me to learn many things about the experiments, and then physical ideas, principle with which instruments are being operated. So this really helped me learn a lot to learn, and these are the facilities that are available, and there are many users now, and our publication level has raised in the university. Impact factor, everything has been raised because of these facilities that have been established in our university. Starting from 2005 up to 2018-19, I was there. 19 till 19, I was there, and as a dean also I have been able to develop many things in the center. So this is what my contribution in terms of research, and of course in the teaching parts, I started developing interactive part of the material in the year. This is 99. The year 1999, I was away for one year at this place. At that time, there is not much facility, research facility at this place. Then started publishing this work, whatever has been developed for teaching purpose. This interactive computation and the simulation of black body radiation, I started using at that time itself in Mathematica. So this is published in the year 1996 Education in India. So now this is being compiled, and along with the other papers, this is the simulation of quantum wave packets, evolution and propagation through the potential in interactive approach. And you can see this is the another interesting aspect. So the interactive package has been developed, and the parameters have been varied, and that's all given in the form of manipulative materials. You can really see the variation of the parameters, like wave packet width can be changed, energy can be, or velocity can be changed, and see when the propagation, with respect to propagation, how things are happening. Now it is still much easier to do. At that time I have tried, but I did it with Fortran and little bit on Mathematica. Now it is amazing with the kind of techniques that have been developed in Mathematica. You can really see things elegant way, and you can do the wonderful algebra also. And this is the inspiring quote which I experienced personally myself. I have greatly experienced the words of our great scientist and most respected past president of our country, Dr. APJ Abdul Kalam. So learning is creativity. Creativity leads thinking. Thinking provides knowledge. Knowledge makes you great. So this is very much experienced over the years, and thinking is a capital. Enterprise is the way, and this is most important. Hard work is the solution, which I have experienced over several years, starting from my PhD career onwards. I feel that there is something has been done and something has been contributed. And according to the Feynman view on science, if any scientific idea proposed disagrees with experiment, whatever be the nature of the experiment, okay, if it disagrees means it is wrong. There's no question about it. So you have to have whatever the idea which you are giving, either in terms of experiment or a model, that all both experiment theories should go together. And another thing is, once he said in the class, you do not know anything until you have practiced. Unless you practice, you cannot learn things. And if you follow certain steps, okay, like procedures, steps of this procedure, conceptualize things, categorize, analyze, and finalize. Okay, if you do that, you will find easier to come up with a solution, gain more from your efforts. And another interesting aspect from these great people, we cannot solve the problems with the same thinking when we created them. So we need to have a different kind of thinking now when you look at the problems. And if you wanted to impress people, make things complicated. If you want to help people, make things simple. So in fact, this is what I would like to do. I want to make people to help people, so make things simple. So that's what we try to do through this Mathematica, with all this mathematics and the visualization effect. We try to do this. So now you can see visualization of the topics. Now you can see, we say there is a physics, and you can see how this physics has been branched out. So this is the kind of visualization which means once I say, this all automatically comes to our mind. Then what we will do, so this is actually the hyperphysics which is available, and this is actually created by this C.R. Neil, Georgia State University. It's one of the fantastic software tool that is available for learning physics. And if I click mechanics, and you can see, visualize it again, mechanics, you see what are the things that are there, and which will be most of the time you'll be learning. And keep track of things and connect them properly, and go from one to the other. That practice once, if you learn, then it will be possible for you, your learning process will be much easier, and you will be able to connect it, and you will be able to remember things, what are the formula or expressions you need to have, and what would be the physical idea that is involved. All this that can be done. With all this understanding, only people have created such links. Okay, so for example, you take this mechanics, you have velocity and acceleration, you have a periodic motion, and then you have Newton's law, mass, force, and gravity. Work energy starts from here, it comes through this connected here also, conservation of momentum, conservation of angular momentum, energy, then circular motion. You see the things have been very nicely connected. For example, this is mechanics, and if you go to the electrodynamics, you can see electricity and magnetism. I don't have to tell the application of this. Okay, life becomes impossible now if you don't have this chemistry and magnetism. Okay, now you can see the things that are get connected to each other, and this goes and sits over here, okay, along with the main part of our physics lane. So like this, every topic that is being generated like this, and really that visually that has been created, and one can really note down all these things and keep track of them and try to understand things. Okay, that will be very easy, and you can remember things, many things that you can remember, okay, through such things, including mathematics. Visualize the mathematics through this. You have trigonometry, algebra. This all will be used in our physics courses. You cannot escape from any one of these mathematics. If you escape, then you are not going to do a good physics. It's not possible to generate a proper or a good physics where you have the combination of your experiment and modeling, that will be failed. So in fact, physics, mathematics is a language of physics. So it is impossible for us. You should have a in-depth knowledge about these things. For example, what do you mean by an exponent? I spend so much of time to understand about what is the E. Through Mathematica, there are many things have been done to understand about E. So there are similarly differentiation. What do you mean by a differentiation? What do you mean by differential equation? Vectors, eigenvalue, eigenfunctions. okay, geometries. So algebras and connection to the geometry and vectors, the linear algebra, all are integral part of our courses. So therefore, it's necessary to have some connections between them and between to the maths. We're not going to focus on mathematics part of it, but our focus may be on physics, but you need to have the knowledge about this mathematics. Similarly, when you talk about the materials, you should have some idea about the chemistry. In fact, our School of Physical, Chemical, Applied Sciences, where you have the physics, chemistry, and earth science, 3 departments are there. There are about 60 faculty members. As a dean, I have been coordinated with them. Everybody, little bit of contribution that they make, they used to discuss. That has made me to learn the importance of the other allied areas also. It is for allied areas for me. For a chemist, it is his own area, but you need to have knowledge about the physics. Similarly, geophysics or earth science. We have a department, strong department of earth science in our university. These are the links. These are actually given by a physicist, Carl Nave's Hyperphysics text. He has given all this information. As a physics person, we feel that you should have knowledge about these things also. It will be useful for us to understand about the connection between the various topics that are there in the geophysics, even though we are working on geophysics or physics alone. This is the biological science again, that's also important. So we have done some dielectric relaxation studies on the blood samples. And we have done something on the water. So we can see that blood sample is connected to these biological things, and we try to understand the dynamics which is involved in those things. So therefore, the knowledge of this is also important. And nowadays, my biology slowly mathematics is taking over. So it is necessary to have all this. Visually, one should have this kind of pictures that you should keep it. Now, when it comes to the physics problem, solving, visualizing physics problem, what is the purpose of that? So we have to provide a material medium or the materials for students or beginners, so where they can investigate space-time evolution of the system on a various manipulative parameters, input parameters. Which means you make it working condition to them and make their learning very comfortable by providing the space-time evolution systems on with the variable parameters, and let them make them to learn. And that also provides they gain vital physical intuition via active exploration of the physical conditions. So when you develop such things, we make sure that these two things should be, keep it in mind, so that when they learn through the Mathematica, these two things should happen. Any topic, whatever they learn. So now some of the things which you can think when you start looking at things computational way, looking at the physics problem with Mathematica, there are many advantages. I've listed out here, and you would see when you complete one problem, then you would realize that all of them are really correct. So one is forced to think very precisely. Gaps in understanding must be eliminated if the program is to work. So when you make it program is workable, then by the time you are sure that it's going to be some little bit of gaps that are there that will be eliminated. So one is forced to think very precisely. That happens when you wanted to reproduce the results and see the intricate things that are happening in your physics problems. So you can do dozens and hundreds and thousands of cases can be examined. It's also true. Perhaps new models and phenomena can also emerge. Methods of verifying the results must be worked out. We'll be always trying to cross-check. For example, if you say quadratic equation, two roots are there, whether this root is right or wrong, how do we verify? Start verify it, then you will try to understand more about it. So once again, adding one's overall understanding, that's going to happen. Okay, any algebra which you do, you try to cross-check it, whether that algebra is come out properly or not. Various other means. Different proofs of the same theorem can be compared with the point of view of algebraic efficiency. For example, factorial and factorial, okay, can be written by using Mathematica about 15 different ways. Okay, I can check it. Okay, so it's possible to understand them, and then you'll really see which is more efficient. Okay, because it's going to be a big number that's going to be generated. So those things are, one can really, unless there are many situations that even physics problem we try to do. One can examine historically important ideas from the varied perspectives provided by Mathematica. Often we'll obtain a new insight also by doing that. So these are all the things that's going to happen when you really try to do problems with the help of a Mathematica, which is available as one of the most modern tool for doing science, engineering, and technology. So the message from my experience, you can become a good physicist by having certain level of talent in mathematics. This is must. This you have to gain it over the years. You should be fascinated with understanding of the way things work. Continued fascination is important for a long, slow road to your physics career. And by continually learning every year of your life, you can realize these things. You're learning continuously over the year. You cannot master the physics quickly. I don't mean an ability to learn quickly, but an ability to learn correctly. This is very important. You can learn quickly, but we learn really correctly. Once you learn goes correctly, then you start think about that problem and is there anything can be done over that. Okay, so with a bit of skill and talent, the perseverance and an aspiration to learn, a little luck and the right teachers. So this also should happen in your life and career or institution. You can go much farther than you would ever imagine. So this I really experienced these things in my career over these years. Okay, now we'll come to the real problem of this. Okay, now you can see what and how will you do physics. As our Vice Chancellor also indicated, there is a loop being created here in terms of the observation of the physical phenomenon and improved observation. This is given in this paper. This sort of a chart is given, but is available in this. Now you can see this loop goes on. Okay, continues for year and years and years and years. And there is a development on experimental aspect of it. For example, resistance, you know, it's a ohms. Now resistance can be written in terms of a fundamental constant H and E. H by E square is a resistance. Amazing thing that happened in the defining the resistance from beginning to now, people are trying to use as H by E square as the resistance. So this is a measurement of a Hall effect. Hall effect will become a quantum Hall effect. So you can see this great thing that has happened in this area of Hall effect or electron properties or electrical properties of material in the presence of electric and magnetic field. And then modeling aspect. See, this modeling is a challenge in terms of understanding the quantum Hall effect. The Hall effect has become a quantum Hall effect in terms of H by E square. And you have the mathematical modeling, mathematical solution, physical interpretation, checking the solutions with observations. This goes together. This loop also growing. It's also growing. And nowadays, I believe for both of them, computers play a major role. You cannot avoid this. Okay, it's impossible to roll out the use of computers. And exercise problems for learners, this also play a role. And researchers, they also play a role. Okay, so this is sort of a crude way of looking at the scientific way of approaching things. So this is, one should keep it in mind. Okay, so this is growing and this is growing. And I would like to state here the Bernard's statement that the science is always wrong. It never solves the problem without raising 10 more problems. It is true. That's why there is a growth here. But we felt it's only Hall effect. It became a quantum Hall effect. Ceramics became a superconductor. This is a great observation. Okay, like this, there are many things that are happening. Okay, right now, yes, there's some disturbance. So now there is a question by a student some time back when I was doing my lecture. He asked, sir, you are saying there is a cycle, this is going on. Now, what is the final growth? What is the as on date, how much the physics has grown? It's a question by him. Seems to be a difficult question to answer, but it's a question raised by the student. Then I really felt that should be answered. So with my understanding, with referring the all possible text, and finally I have come out with the result or an answer saying that this is what the growth of the physics, ECGHK. Okay, if you add one more or break this, it's going to be a revolution. Okay, so if somebody can break this or add another one, it's going to be a revolution. I'm sure about it. This is what the growth of the physics. In fact, physical science uses all of them. Okay, physical science, all of them is being electronic charge. This electrodynamics complete. Okay, field theory, whatever you call it, this E is the starting point for us. Velocity of light, G, the gravitational constant, H, Planck's constant. Okay, these numbers, though they are all very small and very big, they are all very, very important numbers, and you get a strong feel if you work more and more towards understanding these things. Okay, so this is what our aim also, to understand this, and is there any possibility of making an additional physical constant or break this physical constant? Somebody can come out with this, no, the H is not the ultimate, if something else, then it's going to be a breakthrough. This took at least 120 years back, it has happened. Okay. So now this is the one which is going to play a role, that with this we are going to say that my life becomes very simple and I use this computer with the modern software that is available like Math. And here is another question raised by the students, sir, how do I understand the quantum harmonic oscillator? I'm able to see the visually, I can feel, okay, visually I can see and feel the classical oscillator, classical harmonic motion. How do I visualize the quantum harmonic oscillator? Here is the picture which shows, which is developed by using a Mathematica, and here is the answer for it. And you can see all quantum aspects are entered through this. There is a wave packet to locate the position. This wave packet undergoes the simple harmonic motion. And there is an evolution of the wave as a function, as of time, the wave packet evolves and the evolution can be seen. That evolution takes place periodically, which includes all about the quantization, uncertainty, wave packet duality. Okay, all this has been built in. All fundamental aspects of quantum has been built in. So after showing this, people felt, yes, sir, we could be able to feel that there is a quantum object which executes a simple harmonic motion. And they will get a lot of understanding about it. And that is being observed in several situations in solid state and condensed matter in radiation physics. You see that there is going to be a wave packet and its evolution that can be there. Interaction of our matter with a wave, all these scattering problems all can be understood. Now, another aspect here, you have a wave packet which is coming from the left and moving towards the right, and there is a barrier. And you can see this wave packet goes and sees this delta type potential barrier, reflected and transmitted, and there is change of width can be realized, and height also reduces. All this that are happening. This is again being generated by using a simple mathematics. So now you can see the tools that are extremely useful. Now you can see the concept of the quantum harmonic oscillator. I'm able to feel, and student also now he can feel it. Similarly, there is a wave packet which is coming from left. For example, particle from the left with a wave packet which is moving toward that. There is a barrier, there is an obstacle here. That's this obstacles and the disturbance to this, and there is a reflection and there is a transmission also takes place, and there is a reflection and transmission interference can also be seen here. That also can visualize here. Okay, these are some of the details which are available. Some of them are available now. It has been improved lot, and the materials are available with me. All this are we are trying to do finally to produce a gap products and gadgets that benefit humanity, keeping the nature intact. This is very important. In fact, the consequence of not keeping the nature intact, we are realizing now. So therefore, it is important that we have to really keep nature intact. Okay, if you don't do that, then we will have a big consequences like what we see now in the entire world. Okay, this is all about it, and we will see how we are going to use this. And this is the person. This is his achievements for the years. How much he has done that can be seen. A physicist, already somebody has hinted that, and at the age of 15 he has made a publication. I have seen his first publication. This is PhD, the age of 20, worked in these places, and he is now president CEO of the Hyperphysics. That's a great thing that he has done. Now version 12.1 s come out, and you can see the growth of the version 12. Now something like 6,000 mathematically defined functions that are available to do your science, engineering, and technology. You can do all these things: symbolic, mathematical computation, numeric, visualization, algebraic manipulation, data analysis, graph computation, interactive computation, image computation, geometric computation, audio, all image processing, everything can be done with this. Now I experience all of that. That much I have experienced at every stage of it, starting from 1 onwards to 12. Now here is the typical number which is being generated, pi. The number, pi day. This is March, 14th March, 3.14. 14th March is the pi day. For celebrating the around the world. This is the number. And I have taken the real digits. Pi minus 3 means 3 will not be there. These are the decimal numbers. And you can generate the numbers. Okay, this is 1000 digits are there. You can have a 10 power 2, 10 power 3 digits, 10 power 4 digits, 10 power 5 digits, 10 power 6 digits. In fact, you can see 10 power 1, 2, 3, 4, 5, 6, 10 power 6th decimal. What is the 10 power 6th decimal in pi that has been found by using this Mathematica with in a time of say 0.04, say 573 seconds? That is the number is 1. Okay, and you can generate any such numbers, and you can find out how many ones are there in this, how many twos are there, how many threes are there, put them in order. For this 10,000 or 1,000 digits, you can see number of zeros are 93. The number of zeros lying here. Okay, number of 1 is 116. All can be done like by one line. Okay, okay. We try to do that. This is what we are interested to do. So we want to have a capability of the sorter to that extent. That's what we would like to verify and see that whether that can be used, that can be obtained. You can hear 1,000 digits. Number of 9s are 106. I have put in a shorted form 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 digits are there, 0 to 9. How many each one of them are there that can be found within fraction of seconds? I'm able to locate 1,006th digit within this short time. This is what 5. And if you wanted to see that, I just created a small program to demonstrate that, to see how powerful is handling these numbers in Mathematica. This is what your number, you can see pi numerical value. I wanted to have a pi up to starting from 10 digits to 10,000 digits in steps of 10. I'm able to see these numbers. Probably I have to enable the dynamics. Now there is a dynamics, generating the dynamics now. Generating number is the dynamics. Okay, you can see here the numbers. Go on, go on, go on, go on. Now I have generated the 10,000. 10,000 digits are here. Okay, amazing to see such numbers. And you can analyze the numbers. There are very many great things people are trying to do with this Mathematica, with the pi. With the pi, people are doing wonderful things. Okay, I hope I'll be having the next slide showing that, yeah, you can see 200 billion digits that can be analyzed. How many zeros are there? 1, 2, 3, 4 are there. That also has been shown here. Okay, so that is the beauty of that number. And you see the power of the number capability of this Mathematica. Here is the number E. Look at the E. You know, this is an exponential e power 1 is this number. 10 digits of this. Okay, you can generate. This is an irrational number. This is also an irrational number. It goes on and on. I have generated 10,000 digits of the pi. I'm sorry, E. This is never-ending numbers. Okay, and you would be surprised. There are questions. How does it possible to generate such numbers? What is that he's trying to do? These are all the questions which you raise and look for answers. And we are happy with the 3 or 4 digits of the decimals in both the cases. There are just towards understanding these things also. And amazingly, that you can see one number never ends, irrational. Another number is also never ends. And you combine with an I, which is square root of -1. And you combine all of them with the +1. E power I pi +1 is going to, so you can see the 0 here, 1 here, amazing pi sits here, amazing I is all there, then amazing E is there. These are all very, very fantastic numbers. And if you try to know more and more about it, you will understand more about the understanding the process. For example, exponential is the natural growth. Exponential is a natural growth. I cannot have a 2 power n, 10 power x. That's not a natural growth. Natural growth is the natural logarithm, which is, we call it as the natural logarithm E. And how do you arrive this number 1? What makes this number E so great? If I don't have I, okay, here square root of -I is not there, it's completely different. So e power ix, e power x, they're completely different. And this magic comes through the I. And we do a lot of things in physics with this i's. The complex quantity square root of -1. So that through E, we do wonderful things in physics, and we'll understand so much about the physical process that are happening in the natural course of dynamics. Okay, so this is a typical thing which I felt I should show it. And there is another thing also which you can understand how powerful is this source of Mathematica here. This is the number. And a small digit game which you can try, and people can understand how important is such software and how much time one can save in our lifetime by having such things.